All right. Hey, everybody. Thank you for attending today's meetup. Thank you, Bariskan and Catherine, for the incredible presentations. Really, really cool work. I was at CVPR as well, and I was not presenting anything, but I think I caught a cold. So apologies, everybody, if my voice is hoarse or if I break into coughing during this. I'll try to keep it pretty short. So I just got a few slides for you, but I'll spend most of the time really going through a notebook, and Jimmy's going to share the link to the notebook as well as other resources in the chat. But my name is Jacob. I am a machine learning engineer and researcher at FiftyOne, the company that sponsors this meetup. So if you'd like to, feel free to connect with me or follow me on LinkedIn. Here are some of the resources that we're going to be looking at today. So if you want to just do this offline, feel free to just walk through the notebook. It should have everything that you need. That being said, I think that there is some value to understanding and hearing kind of the process that goes on and why you might want to do these types of things. So we're going to cover high level and the technical details in this talk. And then in addition to the notebook, there is a blog post that goes over some of the machinery of how this actually is made. And then we have integration docs for how to use this integration. But at a high level, what I'm going to be talking about today is how to connect your data and your models. So if you work in machine learning or computer vision or AI or whatever you want to call it these days, typically one of the biggest problems that you have is figuring out how to connect the state-of-the-art models, either it's a fine-tuned or a trained from scratch model that you have, or some off-the-shelf pre-trained foundation model to your specific data set that is built for some particular task. It could be a classification task, a detection task, a depth estimation, some custom task, whatever. So in the past, that would involve writing a lot of custom code, but thanks to the integration between Hugging Face and FiftyOne, which I'll be talking about today, that's a lot easier now. So I'm going to walk you through that. And thank you, Jimmy, for sharing resources. So I'm going to toggle over to this notebook over here. And this is the same as the Colab notebook that you'll see if you clicked on that first link or if you scanned the barcode or whatever else. But we need a few libraries to use today. So we'll need the Transformers library from Hugging Face. So at a high level, the transformer model is a paradigm or a type of model architecture that has really made a lot possible in machine learning. Apologies if this is too much background, but the T in GPT from OpenAI is GPT-3, GPT-4 stands for transformer, and it actually formed a lot of the backbone for the work that we already heard about today from our two prior guests. But we're also going to need the Transformers library from Hugging Face, which will provide us access to a lot of transformer models for not just some multimodal and LLM-based tasks, but also some vision tasks. So something that people don't really know necessarily is that transformers have had a lot of success in the visual domain as well. There's something called the vision transformer, which is the backbone for a lot of things like classification and detection, and even things like depth estimation models. Like you have these really dense prediction transformers, which basically predict something at every single pixel across the entire image. The point is they're super powerful, super flexible. This paradigm has been incredibly transformative for machine learning. No pun intended, kind of pun intended, but this library is going to provide us access to all of that. The Hugging Face Hub is going to provide us access to a bunch of data sets. So if you've gone on to Hugging Face before, and we can toggle over there real quick and show you what the Hugging Face Hub looks like. You can see all of their data sets, and this is just huggingface.co/datasets. If you're interested and you want to try this out yourself, they have data sets for all these different tasks, things like depth estimation, image classification, like I've already said, image to text, text to image. So text to image, like generating an image from a text prompt, or you could do this for video as well, or image to text like captioning or VQA types of things, natural language tasks as well. So we could click into any of these and say, okay, I want to see all of the data sets for this particular task. And I'll look into one of them and I'll say, let me look at, for instance, this one over here, this Food 101 data set. And this is not the only place that one could get access to the data set. But this makes it more democratized. It makes it easier to see and share and load data sets. But when you're looking at these data sets, and these are typically in a Parquet format, which is a relatively efficient tabular type data format, which allows you to represent a lot of different types of things, including things like the images, as well as labels. But it's not necessarily easy to, when your data in this type of format, interact with, filter, query, or apply models to this data. And sure, in this case, we just have class labels, and this is a classification data set, but you can imagine it gets much more complicated when we have things like detection data sets. And we've got a bunch of these objects, which are in some format that we'd have to decode and figure out how to actually parse and interpret and all of that. So FiftyOne is going to provide us an easy way to take these data sets that are in Parquet format and transform them pretty automatically into a FiftyOne dataset format that will allow us to more natively work with this visual data. The FiftyOne library. So just to reiterate, FiftyOne is an open source toolkit, like the other libraries that we're dealing with today. It is an open source toolkit for curation and visualization of these types of visual data, so images, videos, point clouds, LiDAR, radar, meshes, PDFs, all that type of stuff, and then UMAP. So this is a library that allows us to use a dimensionality reduction technique called UMAP, or Uniform Manifold Approximation and Projection. If you've used something like PCA before, Principal Components Analysis, this is pretty similar, except I tend to like it a little bit better because it has stronger mathematical foundations. So it gives us a little bit more robust like feature understanding and structure extraction from both the local and the global scale. So lots of overview there, the libraries that we're going to need. Let's actually get into the code here. So with FiftyOne, we have the base library. We've got the FiftyOne Zoo, which is going to provide us access to things like all the data models that you can get directly from FiftyOne, and there's a ton of them. All of your favorite traditional visual data sets, like your ImageNets and COCOs and CFAR and MNIST and all those things, but typically not some of the more niche ones. And if you want to share your own data set, it's probably not going to be in the Zoo. So that's where things like this Hugging Face integration come in. So you can push or load data sets from the hub with ease. So we have this Hugging Face utils right here where you can load from hub, and we can say, hey, I want to load a data set that's in a Parquet format from the Hugging Face hub, and I want to take these fields and treat them as classification fields. So if I go over and just look at this data set again, let me look at WikiArt here. And this is apropos given the Van Gogh reference in our prior talk, but here is a data set from the Hugging Face hub that's pretty popular over here. We've got things like these artists and genres and styles. So all we need to do to specify that we want these to be treated as classification fields in FiftyOne, to have that semantic information associated with them, is to pass in this argument right here with the names of those fields or those columns, those features. We can say, I only want this many samples. You can get all the samples if you want. You can download them in chunks. You can do whatever you want here. There's a lot of flexibility. We can name it something. We can choose to overwrite or not overwrite our existing data set. But I'm going to do this. I'm going to load it, and this should work pretty quickly for you as well. But once we've done that, we can print it out, and we can see what the data set looks like. We can inspect it programmatically. So we can see here that we have things like this artist field and style field and genre and a lot of other things as well. But I can look at like the first element. And by first element, I mean the first sample, because in FiftyOne, when you're dealing with visual data, oftentimes rows are not the best way to think about this visual data because it has a more flexible schema. You may want to think about these things as samples, which have flexible schemas, and some might have metadata of certain types and not other types, and of varying sizes and shapes and all that type of stuff. So this is our first sample in the data set. We can see the path to this image on disk, tags. We can see our classification fields that we generated. And that's cool and all. We can programmatically work with the data. We can extract all the values for a particular field or whatever else. One second. Apologies again. I am getting over something. But we can also visualize this data. So we can use the FiftyOne app, which should load in a tab in your browser. You should go to localhost port 5151. And if you don't know where this is, you can also print it out here. And then you can just click on that, and that'll take you right to the app. So this is a session of the FiftyOne app. And this allows you to interact with all this data. So if we wanted to look at just the Van Gogh images, we can do that. So now I'm seeing just the images or just these paintings, these works of art by Vincent Van Gogh. I can do lots of other types of analysis on this as well. Okay, that's cool. I can do things like get all the distinct artists or styles or whatever else. But I can also apply model to this data. And in general, when we have a transformer model from the Hugging Face Transformers library, the way that we go about applying the model to an image is we will load the image, the model class. So in this case, it would be like this bait. This is a type of transformer. And then we'd have the task for which we're going to use it. We would also load the processor class for that particular model or an auto and have it figured out on its own and kind of infer. We would take the image. So we would use the pillow library in Python or something of that nature. Maybe we would stream the image in. We would open it up. So here I would take the first image in the data set from the file path of that first sample that I was looking at before. We would look at it, and then maybe we would do something like this. We would load it. We would use torch.nograd to say we don't want the gradients. This is just an inference task. This is not a training task. And then we would decode all the information and then try to interpret it and maybe store it in some way on our data or in some CSV file or something like that. But with FiftyOne and the integration with the Transformers library, this is all taken care of for us. So instead of having to deal with all this stuff, you could just take the model from the Hugging Face Transformers library and just apply it directly to the FiftyOne dataset. So I can do something like this. And here I'm just doing it for the first 10 samples. It's pretty quick. I'm going to go over to the app. I'm going to reset this filter. I'm going to refresh. And now we should see this bait, this new field that we just created that has information on it. So here I can see this one says, and we've got a book jacket, dust cover, dust jacket, blah. Here we've got a lawnmower. Here we've got a beacon, a lighthouse, and whatever else. And this is just a random model that I chose. So the classes in this multi-class or multi-class classification problem are probably not going to be super appropriate. But I hope that the point comes across that this framework for taking models from the Hugging Face Transformers library and just applying them to your data, as opposed to having to do all the pre and post processing and figuring out all that stuff on your own, is really powerful. And we can do this for other tasks as well. So depth anything is really popular right now. In particular, depth anything v2 just came out. Here we're just going to apply the original depth anything model, but we're going to generate these depth maps for each of the first 10 images in our data set. And we're going to go back over and we're going to refresh. And then I will turn on this field. And we can see that then we now have depth maps on those. And then we can interact with these depth maps if we wanted to. We could filter based on properties and so forth and so on. We can also do this with other types of data sets. So here's an example of a object detection data set. I already downloaded this one, so I'm going to try this again here. But the idea is that this data set is a personal protective equipment data set that was in vogue around the time of COVID. And we're getting some errors in the Hugging Face API here, but we already have the data set downloaded, so we're just going to use that. In your case, you can basically just, it's going to download all the images in batches, and it's going to save its progress. So even if it encounters issues with the Hugging Face API, because this is a server that it has to kind of ping every once in a while, it knows where it left off. So it doesn't have to start from scratch. It basically saves all of that work, and you can just download the next couple of images and so forth. So I can then go over to the app, and I can choose from my data set. And here I should be able to, let me just do 500 here. We'll see if this works. I mean, we work, so the internet, we'll see if it holds up. But the idea here is you should be able to, regardless of the number of images, regardless of the dataset type, it should just work. So hopefully this finishes up right now. And while that's going, the next thing that we're going to do is we're going to use some plugins. So in FiftyOne, we've got these basic transformer models. I'll do this one more time. This one data set might be causing issues, so I might have to try a different one. But we have a bunch of plugins. So in addition to this, our traditional like classification and detection and segmentation models, we have plugins for specific tasks as well. So you can just use the FiftyOne command line interface syntax to download plugins for like image captioning or visual question answering or text to image generation that use diffusion models from the Hugging Face diffusion library. And then you can use all of these from within the FiftyOne app in your data set. So we're going to look at some of these, and you can see the syntax. This is all in the notebook that you'll have access to, but you can basically just run this, and it will download the plugin and install it for you in the appropriate place. So if I go back over here, I'm going to reset this. I'm going to restart here. And close this down. And we should, if I get out of this, I close Chrome, blah. Hopefully this works. Apologies for the issue. Demoing can be kind or not so kind. It seems to be throwing a tantrum right now. I'll try one more time. We have our data set here. So now let me just try. Should be working. There we go. Cool. So we've got a data set. This is just our standard subset of Cocoa, but we can also go to a different data set. So I go back to the WikiArt one we were dealing with before. And now we're going to use a plugin. So I'm going to use a image captioning plugin, and I'll choose a model. Here I'll choose, I don't know. Let's choose Blip2. And I'll just do it on the first 4 images. I'll turn all this stuff off. We're going to caption using this Blip2 model. And I'll save this in a field called Blip2 caption. So this is going to go through and iterate through all of those 4 images. And it would do however many images you have. You could do this in delegated execution mode. You can do this in real time. But here, I now have, this is a caption that says a drawing of trees in a lake. I've got a caption that says a black and white drawing, a young man in a hat sitting, a woman sitting in the grass. You can apply any of these models. Some of them are from Hugging Face transformers, some of them are from Replicate, wherever else. You can apply text image models. So here I can take a model from, for instance, let's use a latent consistency model from the diffusers library. And I'll just to keep it in the same theme as all of our other images here. We're going to do something artistic, and I'm going to execute. And this is going to run locally. So if it needs to, it'll pull the model and download it. And it will then generate the image based on your specifications. And it will add that image to the data set. And it'll refresh. And then you can actually filter and you can see all that stuff in the future. So you can add as many images as you want from however many of these types of models as you want. It'll keep all the config that was used, the prompt that was used, all of that. Here it's going to be slow because I'm actually running it locally and I'm working on a Mac. And this is a Mac M1 from like 2021. So we'll see if it actually finishes up. I'll give it a few more seconds here. But you can also use like an API, which will run it on GPUs, or if you have access locally to a GPU, that might be good enough for you. But once we do this, we're going to finish up with one more thing. And I won't get into things like zero-shot prediction. You can apply things like OwlBit and grounding dyno and a lot of other of these zero-shot models for different tasks. You can apply transformers directly from the app for things like classification, detection, segmentation, and so forth. You can use these to do dimensionality reduction, to do similarity searches, lots of other cool stuff. But what we're going to do at the end here is we're going to take this data set and we're going to push it to the hub. So hopefully this will finish up real soon. But this push to hub is going to take this data set that we have been working on. We have been altering, been adding some predictions to, been adding some samples to, and we're going to push it with our Hugging Face username or organization name. We can choose the name of the data set, the repo that we want to put it in. We can choose a license if we want. We can choose a description. We can add a preview path to an image if we want. So if we want this to basically have an image to show people what the data set looks like on that page, we can do that as well. And hopefully this will finish up. I might just do a non-local one to show you what that looks like real quick. Let me cancel out of this. My computer is not cooperating right now. So I'm going to just use Stable Diffusion and we'll do this. Well, should be much, much quicker. So it might have had to download that model for me. Every once in a while I go through and clean out my my cache. If we go to the very bottom here, we'll see this new image that we just generated. And this has additional attributes on it. So we have like the prompt we use to generate it, the date created, and we have this whole config here, which has things like number of inference steps, the scheduler, and lots of other cool things. So we've got the data set. So if I do echo.load data set, and I'll just make sure that we get the right one, wikiart 100. And now we're going to push it. And I'm going to do this. I'll just put the date on here, June 27. And I have to load this push to hub from 51.utils.face, push to hub. And now 101 samples, not 100, because we added that one. It's going to export this to a temporary directory. And then it's going to upload these, and you can upload them in chunks if you want to. But once it does this, the data set will be available to actually look at. It'll be uploaded in FiftyOne format. So you won't have to do any of that custom configuration and specifying with arguments what the specific fields are for different tasks in the future. It'll just work, and you can just download it like any other FiftyOne data set on the hub. So if I go to the Hugging Face hub, and I go to my profile, and in your case, it would be on your profile, I can see that there's this new data set that I just generated here, and it has instructions on how to load it in the future. You can add whatever details you want. It has all the files here, as well as the metadata for our samples. And now you can share it with others. And it's got this FiftyOne tag, which allows you to also see all the other data sets that are in FiftyOne format on the Hugging Face hub. And there are tons of cool things to play around with here. So that's all I have for you. The important thing that I want you to take away from this is that uh, barring all of the difficulties with the demo, which just happen every once in a while, uh, the Hugging Face 51 integration allows you to more easily connect your data and your models. It allows you to apply your models to your data, to load data in Parquet formats, to push your data set, to share it with others, to do things like VQA and generate images and add them directly to your data set. Use state-of-the-art models for all these different tasks that have to think about the particular formats or any of those details. So hope you enjoyed. I'll stop the share here. And thank you for sticking with it.
All right, Jacob, if you want to jump into the Q&A widget, looks like you have 2 questions.
So the first question by Paul is if FiftyOne uses the Hugging Face datasets cache. That's a great question. So we actually don't, because that way it would create some duplication. So we store everything in the FiftyOne directory on your computer. So in the FiftyOne, you should be able to see where your datasets are downloaded. If you go to your fo.config in Python, you'll see where the default dataset downloader is. And if you look in there, it should be in Hugging Face /hub. You'll see all the datasets. This is so that we don't we're not at the whims of all of that cache stuff, and you don't have datasets potentially duplicated in multiple places if you make updates and other stuff. Cool. Then there was another question about for zero shot or caption generation detection classification. If you want to use a custom dataset after reviewing it through the Wolfram 51 UI, can you remove or pre-process the faulty data directly in the UI? Absolutely. So I didn't show you any of this stuff because 51 is super flexible and there's too much to show in any 30-minute window, but 51 has operators in our plugin ecosystem. So plugins are some of the things I showed you with VQA and captioning. We have some built-in plugins, core plugins, which allow you to get access to all of the Python SDK operators to do things like delete sample fields. So you can delete all of the fields that you don't want if you generated them mistakenly or if they contain bad information on them, or you can delete specific samples, or you can tag samples as mistakes, and all this stuff. All that is possible from the UI. Basically, most of the things that you would want to do in code, you can now do in the UI.